Hi everyone, welcome to this second chapter of the Security for Developers, for Salesforce Developers webinar series. My name is Alba Rivas. I am a developer advocate at Salesforce, and here you have my contact details in case that you want to contact me later. Sorry, not here, but in the next screen that I'm going to show. But during the webinar, you can ask questions in the chat window because I'm going to be monitoring it and I will try to answer as many questions as possible. So with that, let's start talking about today's webinar. Today we are going to cover application security. In the first webinar, we saw everything related to data security, object level security, field level security, record sharing, etc. And today we are going to focus in different vulnerabilities that can affect your application security and how you can prevent them in Apex. Great. So, of course, our favorite slide, forward-looking statement slide, which just means that as Salesforce is a publicly traded company, you should make purchases based on the functionality that is generally available. But everything that we are going to cover today is GA. Okay, so to summarize, this series is a series that I started last week, the previous week, right? And it's going to have 3 chapters. The first chapter, data security. Today we are going to talk about application security. And in the third chapter, we are going to talk about sensitive data storage, which is another important topic in regards to security and what Salesforce developers must know. If you're a Spanish speaker, I'm going to give the same webinar in Spanish starting this Thursday. In this, I'm going to have a very special person here with me in the Spanish webinar, which is Julián Duque. You probably know him from other webinar series that we have given. And if you want to join those webinars instead, those are going to be the next 3 Thursday in the next 3 weeks. Great. So first of all, I want to start by answering a question that was asked in the first webinar. Somebody asked how data security worked in Flow, and I promised that I was going to take a look and explain to you how this works, right? So basically in the documentation, there is a help page that you can read if you want to know more in detail about this topic, but I'm going to go to that page for a second and explain to you that for Flow, there is no immediate answer because for Flow, by default, the data security permissions, this is if the flow is going to run in user mode or system mode in regards to data security, right, are going to depend on the way in which the flow is invoked, right? So it depends on your specific use case and you will have to take a look at the documentation. What I have found out is that for almost all kind of flows except the auto launch flow, but for screen flows, right, or record trigger flows, etc., there is an option that you can use to override that default security setting, right? There is an option that you can pick in your flow configuration that is going to help you configure security in 3 different ways. The first option is the default. It depends on the way in which the flow is launched. The second option is a system context, but with sharing, which means that object and field level security are going to be enforced, but record level security not. And the third one is like a complete system context, same as Apex runs in, right? To show you an example of that, what I did was to create a very simple flow for my security application, right? Remember that, well, this is the admin user the one that is login. But remember, I had another user which is a low permissions user, which who has like all the access to the account fields. For instance, here the user doesn't have access to the annual revenue field, and this is something that we are trying to show here in my flow. And the documentation says, the documentation says that when you run a flow in a landing page, then the user permissions are going to be respected. So let's see what happens when I'm logged in with the low permissions users. And this is exactly what happens, right? It's a very simple flow. I'm not handling the fault paths. So what is happening is that I'm receiving an exception because the user doesn't have access to the annual revenue field that I'm trying to show in my flow. Okay? Hope that this answers your questions. Hola Rafael, hi everyone. If you want to say me hello in the chat window, I'm really glad to have you all here. If you want to tell me where do you come from, what are you expecting from this webinar, or any questions that you may have, I will be super happy with that. Okay, so starting with today's webinar, we are going to talk about application security, right? Application security, it's basically a set of techniques and processes that are going to help you prevent or minimize. Sometimes it's impossible to 100% prevent, but at least minimize, right? All the security risks that your application code may have, right? I don't know if you have heard about OWASP. This is the Open Worldwide Application Security Project, right? This is an organization that every year elaborate a list of the most common attacks that are happening in web applications worldwide. So, for instance, the OWASP top 10 vulnerabilities in 2021 are injection, broken authentication, sensitive data exposure. Remember, the third webinar is going to be about this, etc., etc., etc. Okay? So, if you want to know more about the OWASP, they have a webpage which is owasp.org, and there you are going to find the most accurate, the most up-to-date documentation about application security vulnerabilities. So if you are a security engineer, you'll probably be on top on what OWASP, the OWASP organization, is publishing, right? So today we are going to cover some application vulnerabilities that are listed in the OWASP list, right? That may affect your Salesforce applications, and that you as a developer need to understand how to prevent and, really how to prevent that, not how to fix it, because we want to prevent those vulnerabilities, right? And the first vulnerability I'm going to talk about today is SQL injection, okay? So really the vulnerability like the OWASP one, right, is SQL injection, right? But as in Salesforce we have SQL, then we will call it SQL injection. If you take a look at the list, injection is the number one vulnerability. So this is a pretty important injection. Hopefully we're going to see that in Salesforce is not super important, because the SQL language is designed in a way in which it's hard to open a SQL injection vulnerability, but there are just a few use cases in which we have to take care of that, okay? So so instead of talking about preventing SQL injection, I'm going to navigate to my sample organization in which I have created an app to talk about all these security topics, right? And I'm going to navigate to the SQL injection examples tab, this code is available, right? I'm going to share the GitHub repo at the end of the presentation. And I also shared it in the first webinar of the series because I showed some examples in regards to DML operations, SQL operations, and data security, and also sharing, right? There are some comments in the chat window, so I'm going to read them. Jitendra, hey, hello, thank you for saying hey. Matak, thank you, I'm glad that you like the explanation. Pedro, I think it will be uploaded to this channel. Okay, I guess you were asking about the video recordings. So basically, if you go to the recorded videos section in our YouTube channel, you are going to find all the recordings. And if you want to write like sfdc.co and then security depths 1, security depths 2, and security depths 3, you are going to have the 3 recordings in English. Okay? So let's start talking about SQL injection. So what happens with SQL injection? With SQL injection, what happens is that an attacker is able to modify a SQL query that we are performing in our Apex code to obtain privileged information, right? So imagine that I have this example here in which I have a filter, I have a list of accounts that are being returned from the backend, right? And I'm returning those accounts using different SQL techniques, right? We are going to see that one of the techniques is using like static SQL. There is another technique which is using dynamic SQL, and we are going to see which of them are vulnerable, right? So imagine that an attacker is smart enough and has come up with something that he can indicate in the filter to obtain some privileged information. In this case, the attacker is specifying a string value that is modifying our SQL query behind the scenes, right? And that is getting privileged information because it's filtering accounts by annual revenue greater than 2 million, right? Here we are seeing the annual revenue on the screen just because I wanted to show you that this attack is working, right? It's gaining access to that privileged information of which are the accounts with the most or the highest annual revenue. But imagine that my application is not showing this column here, right? Which would be like the real use case. The attacker is gaining access to an information that is hidden by modifying a SQL query that we are performing in Apex. So this is clearly a problem and a SQL injection attack. But here I have 3 more implementations that we are going to see in a second in code, in which if I specify the same filter, the tweak that the attacker is trying to do is not working because I'm applying the correct techniques to prevent SQL injection in Apex, right? So let's take a look at the code. Let's take a look at the code that is vulnerable, and let's take a look at the code that is not vulnerable, right? So first of all, this is the vulnerable code, right? We are getting filtered accounts, right? We are receiving the search value that is an input provided by the user in the user interface, right? And what we are doing is dynamic query in which we are concatenating like the real bits of the query that I want to execute with the user supplied input. Obviously, what is happening here is that if the user is smart enough to provide a value that allows him to get that privileged information, it's going to be a problem, okay? It's going to be a SQL injection attack. However, The three other different implementations that are secure, the best practice, what you should do, are these three, okay? The first one, just use static SQL. If you use static SQL, as we are binding the value, right, Apex behind the scene before executing the query is parsing this value here, and there's no possibility that this value or anything contained in this string value becomes a part of the query, right? Second alternative, use bound value, right, using column in your dynamic SQL query. This is, if you can, use static, but if you have to use dynamic for any reason, what you can do is to just bind the value. That way, the SQL engine is going to treat this value as a string in any case. So these kind of queries are secure too, right? And finally, this is a more rudimentary way, but it also works. So normally the problem with these kind of attacks is that the user is able to provide some quotes, and that those quotes become part of the query. They are left unescaped, right? So if you do something like this, a string dot escape single quotes of the search value, you are also avoiding any kind of vulnerability because you are escaping the single quote and omitting those possibilities. Okay? Hope that makes sense. Please tell me in the chat window if this makes sense for you, if you have any questions regarding SQL injection, and if you want to know more. Okay? Okay, so I have a comment from Francisco. Your mouse is not synced. Don't use it to point to something, please. Okay, I'm really sorry. I don't know why that is happening. I'm so sorry. I try to not use it too much. Okay, so let's continue. This is SQL injection, right? We have seen the three different techniques to prevent SQL injection. Use static queries. If you need to use dynamic queries, use the bind technique with the column, right? And if not possible, just escape the inputs. There is something else that you can do, which is typecast or whitelist input that may work. For instance, let's say that instead of waiting a user input, which is a string, you are expecting that the user indicates a number because you are going to filter by a field that is a number field, right? In that case, what you can do in Apex is to cast to decimal or to integer the type that you are using, and that way you are going to make sure that what you are receiving is a number, right? And the same for other kinds, for instance, if you are expecting a date or whatever. And whitelist means if you know that the possible values is a discrete set of values. For instance, let's say that the user needs to pick in the UI among different colors. So, and you know that the colors are red, blue, white, etc. So the idea is whitelist those colors, the possible colors, and only allow those control values that you know. Okay, that is another possible implementation in some cases. Great. So now let's continue talking about another important vulnerability, which is cross-site scripting. Normally, you are going to see cross-site scripting shortened as XSS, okay? And if we take a look at the OWASP top 10 vulnerabilities in 2021, we are going to find that this is in number 7. This is in the 7th position, right? Cross-site scripting. So it's still a very important vulnerability that may affect your code. Great. So there are three different kinds or three different ways in which cross-site scripting can affect your code, right? And we're going to see this better with an example. So here, let me go to my cross-site scripting tab, right? And in the first tab, we have what we call reflected cross-site scripting. With reflected cross-site scripting, what happens is that we use a user supplied value somewhere in our code, right? And we evaluate that user supplied value in a way in which it is executed. If the user supplied value is a malicious script, something that executes malicious code in our application, the attack is going to succeed, right? So for instance, here I have an input in which I can supply a value, right? So I'm going to copy this value, right? And what has happened here is that the value has executed. The string value was alert malicious, and what happened is that really a real alert in my application executed saying malicious, right? This could be something very harmful. If we take a look at the implementation of that component, let me open the Lightning Web Components here, is the reflected cross-site scripting, right? So what I'm really doing here, I'm going to close this so that you see it easier. I'm going to try to not move the mouse much, right? So what we're doing is there is a Lightning input. We are defining a handler for the onChange event, and then we are executing this code here. This code here is using eval. Eval is evil, okay? We are allowed to use eval at the moment in Lightning Web Components because there are some third-party libraries that use it. Let's say that we allowed to use it like in a soft way. We are doing some checks, right? But we strongly recommend not to use it because this is an entry point for cross-site scripting vulnerabilities. As you can see here, as I'm passing in the event detail value, which is the user supplied input to this eval function, what is happening is that whatever the user is inputting is being evaluated. And in this case, it was a malicious script, right? So this is what we call reflected cross-site scripting. Why? Because it's something that the user is specifying, is going to the server, and then is coming back. Normally, when we say reflected, it means that it goes to the server and goes back. And when it doesn't go to the server, as in this case, it's more like it's supplied by the user and it's evaluated somehow in the client. It's a particular reflected cross-site scripting technique that we call DOM XSS, right? And I have read today that there is a proposal to rename DOM cross-site scripting as client-side cross-site scripting, which I think makes much more sense, right? But anyway, just remember, reflected, it means something goes and then it's reflected back. But super important, and this is something that not many people know, cross-site scripting may happen because a malicious script is stored in your database, right? And that is what we call stored cross-site scripting. In this example, right, I'm going to show you the code first, right? We have a button. This button has an on-click handler, and if we take a look at the handler is executing an Apex method. This is an Apex method that I have defined in a class which is contact controller. If you take a look here, what I'm doing is to return a contact, right? But what happens is that the name of the contact, obviously is a contact that I have created in the organization, is a contact that is stored in the database, and that an attacker was able to hijack, like modifying the name, right? In the name of the contact, we have stored a malicious script. So what happens here? That if I use the same eval function, over the contact name, then the same problem than before is going to happen. The malicious script is going to be executed, but this time is not something provided by the user. It's something that resides in my database because the attacker got access to the database, right? If here I click on Get Contact, what is going to happen is that, again, this malicious script gets executed. I'm going to show you the contact here so that you see that the name of the contact is the one that was hijacked. Okay, so this is basically the explanation about the different types of cross-site scripting. So now let's take a look at how you can prevent those vulnerabilities in Salesforce, right? So first of all, we have a really great defense against cross-site scripting. This is local service, right? Local service is there for your security, Lightning local service, right? Local service is going to provide a lot of security layers or functionalities, right? First of all, it's going to enforce the JavaScript strict mode, which is much more secure, right? Second, is going to prevent some components from accessing the DOM of other components in different namespaces. So for instance, let's say that you have installed a component from a third-party company, right? That from the App Exchange, for instance, and that component, thanks to local service, you are secure, you are safe, that component is not going to gain access to other components that you have in your page, because local service is preventing that, right? Something safe harbor is that I know that the security team is implementing a mechanism to allow you establish inter-namespace trust. So for instance, if you have components that belong to two different namespaces, but you trust that namespace, then we are going to provide a way to allow DOM access between those two components in a controlled way, right? And this is safe harbor because it's not delivered yet. Then what else? With local service, what we do for security as well is to use something that we call secure wrappers. And for that, I'm going to navigate to the documentation, right? If in the Lightning Web Components documentation, you navigate to local API viewer, to this tab, right? You are going to see that there are here three different objects: secure window, secure document, and secure element, which are modified secure versions of the regular window element, document element, and element in regular web pages, right? We do that for security, for preventing cross-site scripting vulnerabilities, because in Salesforce, as you probably know, trust is #1 value, right? So as a result of this, there are some APIs of the regular elements that are not going to be supported because we consider those APIs vulnerable, or we consider that it is a security risk. And if you want to know which APIs are supported in these modified versions, that are the versions that you are going to use when you interact with the DOM with Lightning Web Components, you can come here and search the different APIs and see if it is supported or not supported by local service. Okay? That's an important thing to know. As I told you, this is the greatest defense against cross-site scripting vulnerability. And finally, in local service, we implement a couple more policies, right, that are part of the content security policy standard, okay? To take a look at that, you can navigate to the development guide, Lightning Web Components development guide. There is a section about content security policy, and they tell you all the CSP restrictions that are implemented in local service to prevent cross-site scripting. For instance, JavaScript libraries can only be referenced from your OR. For instance, resources must be located in your OR by default. Why do we have to locate resources in static resources? For security, because if we allow you to download resources from a third-party page in which there might have been an attack, right? And the library may be a malicious code, right? If we let you do that, then it could be a problem for your application. And that's why we implement this content security policy. By the way, there is a way in which you can download CSS resource and images if you specify a CSP trusted site, but by default we are not going to let you, and for JavaScript for sure we don't let you. We force you to download resources through HTTPS, which is encrypted, and so on, right? I'm not going to cover all the list. I just want you to go out from this talk knowing the importance of local service, right? Because some people think that local service is like a real problem, it's making their life harder, but it's not true, right? It's helping your applications to be secure. So, what happens if I have a code and I want to know if that code is supported by local service? Because if my code has some vulnerabilities, is using some methods or APIs from my window object, for instance, my secure window object that we don't expose because we consider them vulnerable, that code is not going to work, right? Within local. So there is a place in the documentation in which you can test your code. If you go to the local console tab, here you can write some code and click on evaluate, right? When you click on evaluate, your code is going to be evaluated and you can try with local on or local off, right? A strict CSP, I recommend you to have it on all the time because there's no way to disable CSP really in Lightning Web Components. Is there like because of a moment in which this was possible, but that is not possible anymore. But you can try with local on and local off, see the result, right, of this code, and take a look if local is preventing your code from running as you expect it to run, right? By the way, in the newest API versions, local cannot be disabled, okay? It was possible in the previous API versions like a couple of years ago, but that's not possible anymore. So apart from local, so we know now that local is super important, that it's going to prevent cross-site scripting vulnerabilities, but there are, again, a couple use cases, same as with Sockwell injection, in which we need to pay special attention and try to not use those approaches as much as possible because we know that they are an entry point for cross-site scripting vulnerabilities even though local is there, right? Well, the first thing is that we recommend you to stay away from manual DOM manipulation. So there is a directive called LWC DOM manual that we released because there are some cases in which you are using third-party libraries, right? And those third-party libraries need to modify the DOM manually outside of the Lightning Web Components lifecycle, okay? But if you have to use them, that's fine. But if you want to be safe, completely safe against cross-site scripted, we recommend you to not use them. And I'm going to show you an example in which I'm implementing the same code using LWC DOM manual and manually manipulating the DOM. And I'm using, and the other implementation, the best practice, in which I'm not using LWC DOM manual, and I'm getting the same result, so that you understand better what I mean when I say manual DOM manipulations, right? And here in my cross-site scripting tab, I have an example in which I'm doing an iteration, manually manipulating the DOM, and I have another example in which I'm letting the Lightning Web Components lifecycle manipulate the DOM for me, and I'm not hooking into that and manipulating the DOM myself. And you are going to see that in the first case, the HTML code that it's indicated is interpreted, which is a security vulnerability, right? And in the second case, it's not, because in the second case, the framework is going to sanitize my inputs. So let's take a look at the code of these two examples. The first example is, let me see, manual DOM manipulation, right? And in the first example, what we have is basically an HTML tag in which I'm using the LWC DOM manual directly. With that directive, I'm telling the Lightning Web Components framework that I want to manipulate the internals of this HTML element by myself. How am I manipulating those internals? Well, I'm iterating over a list. This list contains like pairs of cities states and their populations. And if you notice in the last state, Florida, I'm indicating some HTML, okay? In this example, I'm indicating the list here, but imagine that this is a value that I'm reading from a third-party web service, for instance, or something that I'm bringing from the database, which could be manipulated, right? So how do I manipulate the DOM manually, and how do I create that list manually? What I do is to iterate over the demographics variable, and then I use the inner HTML property. We recommend against using this kind of properties because this is an entry point for cross-site scripting again. However, if I execute the same or I try to create the same example, but instead of manipulating the DOM manually with inner HTML, I use the template directives that the Lightning Web Component Framework provides as template for each, template for item, template if true, right? Then I'm going to be able to do exactly the same iteration, but this time the framework is going to sanitize the inputs for me. So what is going to happen is that in reality, in this case, I'm safe because the template directive is sanitizing the input for me. So that's very important to know, okay? Any questions on the chat window? Today you are super quiet. Let me know if there's something else that you want to know, okay? So, what else? Well, we have seen that there are some JavaScript functions that by default are an entry point for cross-site scripting that you can use in Lightning Web Components, but that we recommend you to not use in any case. Those functions, we have seen an example before, evol, right? Evol, with evol, it's cross-site scripting may happen super easily. Don't parse from string, document implementation, create HTML document, and set timeout, set interval, right? Because with set timeout, you can pass a function that usage is completely fine, but also you can pass a string that gets evaluated. That case is the use case that is dangerous, okay? Again, there are some more techniques that you can apply, same as we talked about whitelisting and escaping single quotes for SQL injection. Here, the dangerous characters are the greater than and less than characters, right? Because those are the ones that are going to let you manipulate the DOM. And what you can do is to filter the inputs, but also the outputs. Remember that your vulnerabilities may come from the database, right? From the backend. And finally, if you are going to use third-party libraries, if you need to use LWC DOM manual because you are using a graphics library, for instance, that you strongly need to use, right? Properly evaluate their security. There are many tools, scanners out there that are going to help you understand if your libraries are secure. Right here, I have a couple of examples like checkmarks, or Sneak, but there are many others out there. So that's something that you can consider if you are going to use third-party libraries. Great. How are you doing? I see many people connected, but today you are super quiet. I know that this topic is harder than data security because normally you are all familiar with data security because you have to configure that in your organization and you know more or less what it means. And it's hard to understand application security vulnerabilities, but definitely this is something that you will have to take into account, not only if you are going to submit your application for a security review for the app exchange, but also if you are implementing Salesforce for a customer and you want your code to be completely safe, okay? So the third and last vulnerability that I'm going to talk about today is cross-site request forgery. And this is normally shortened as CSRF. So what happens with CSRF? So imagine that this is the victim's browser, right? Your customer. And the customer navigates to Salesforce, they log into their Salesforce org, everything works correctly, and the customer is now logged in. Sometime later, the customer decides to visit a malicious website, maliciouswebsite.com. And what happens that these websites is aware that there is an API endpoint, for instance, or simply an endpoint, right, that he can execute or he can make the customer execute in Salesforce to perform some unwanted actions, right? Something that the victim doesn't want to do. It's something that the attacker wants the victim to do. For instance, an Apex, this is something that I made up, okay? But an endpoint that allows me to delete accounts. When, as the malicious website knows that, what it's going to do is to return a document, an HTTP request, right? Response, that is an HTML document that includes, for instance, an image that points to that action that he wants the customer to perform in Salesforce. What happens, how the browser works, is that when the browser receives this HTML document, immediately is going to try to retrieve the images and to make a request to this endpoint here. So what is going to happen is that the customer is going to delete all the accounts in Salesforce without knowing it, because the browser has executed that way. That is what we call cross-site request forgery. Okay? So in Salesforce, we are lucky, again, same as with cross-site scripting and with SQL injection, because there is a default protection that is going to act in most of the cases. I don't like this slide because it's all test, so I'm going to show you because I have a CSRF sample here, okay? So how does this protection works? So basically, when you are logged into Salesforce and you make subsequent requests to Salesforce, every time the browser sends a token to the server, which is Salesforce, right? And Salesforce every time validates that the anti-CSRF token protection is a part of the request. That way, if an attacker tries to perform that attack, because he knows which is the endpoint that we have to query, he knows the endpoint, but he doesn't know which is the token that he has to use. And that is going to work in most of the cases. There is just one single moment in which that token is not generated, which is the first time that you load a page. In Visual Forms, for instance, this was the moment in which you execute a Visual Force page action, right? That's executed on page load, and that is the moment in which you have to be especially careful with CSRF. And in Lightning Web Components is going to be the connected callback or rendered callback, which are the callbacks that execute when the component loads, right? And that may execute in this first time that the page loads. So, should I avoid performing any actions on component load? No. Why? Because what happens... Sorry. Ooh. Okay. Because what happens if this action here is not changing the database? Nothing. The victim's browser is going to receive that information, is going to navigate to this page, right, really, but it's not going to really perform any dangerous action in my Salesforce org. The problem comes when there is an action that changes the state of the database, for instance, performing some DML operations, right? In that case, this is going to be a problem. So, what should we do? In connected callback or rendered callback, we shouldn't change the state of our database. This is an example in which I have a component that is vulnerable to CSRF. Why? Because if we take a look at the code, what I'm doing is in the connected callback, I'm creating an account. I'm modifying the database. And that is an action. If I reload the page, you are going to see it, that an account gets created, right? And there is an action that is not protected by the CSRF protection, and something that I should bear in mind. Great, so basically is what I said. If you are working with Salesforce, Lightning Web Components, for instance, what you should do is to never execute DML in your connected callback or rendered callback. And then if you are implementing integrations, right, with other systems, then you will have to be aware of what CSRF is and implement your own protections. You could implement a CSRF token system, as we are doing in Salesforce, or you could validate the origin header to make sure that the requests that you are receiving are from known origins, or techniques like that. Okay, so we have arrived to the end of the presentation. If you have any questions, just let me know in the chat window. Again, I know this is a really hard topic, but if you have any questions later while watching the video, or I don't know, or later when you are working with your code and you want to know anything about these vulnerabilities, you can comment in the video, right? So that everyone sees the comment and I'm monitoring the video comments as well. Or you can reach me on Twitter or LinkedIn, okay? Recommended resources. We have a Trailhead module about security in which there is a batch that talks solely about application security, about these vulnerabilities I have talked about, and I recommend you to take a look. If you want to take a look at the examples that I used today, this is my GitHub repo with all the examples for the whole security webinar. Here I leave you also the links for the security guide, Apex security guide, and also the local service documentation, right? And in addition to last week resources, I leave you here also a video that I think it's from Dreamforce 19, in which someone from the security team, I don't remember who was the person, explains very well everything about local service and Lightning Web Components security. Okay? As a reminder, we are in Twitter, LinkedIn, YouTube, the channel that you are watching today, and we are publishing content in YouTube very often. I'm doing this same webinar every Tuesday, and I'm going to do it in Spanish on Thursday, starting this week. If you enjoyed the video, please like it. Also, subscribe to the channel so that you can receive notifications. You have to click on the bell to receive notifications. And let me know if you liked the video, or which was your big key learning from this session, or if you want to know more, okay? Thank you so much. I'm going to pass to the full view to say you goodbye. Thank you so much for joining. I'm loving giving these webinars, knowing that there are many people out there learning from them. I receive sometimes emails saying like, thank you for being there, because it's really exciting for me to have the opportunity to show you what I know. And with this, I'm going to close the webinar. Hope to see you in the next one, which is going to be next Tuesday. Is going to be about sensitive data storage. Thank you so much, and bye-bye.